I'm Dr. Binu. In Artificial Intelligence and Machine Learning Fundamental subject, the sixth topic in the third unit is cross validation in machine learning. Cross validation is a technique used in machine learning to evaluate the performance of the model on unseen data. It involves dividing the available data into multiple folds or subsets using one of these folds as a validation set and training the model on the remaining fold. This process is repeated multiple times, each time using different fold as the validation set. Finally, the result from each validation step are averaged to produce more robust estimate of the model's performance. Cross validation is an important step in the machine learning process and helps to ensure that the model selected for deployment is robust and generalizes well to new data. What is the use of cross validation? The main purpose of cross validation is to prevent overfitting, which occurs when the model is trained too well on a training data and performs poorly on new unseen data. By evaluating the model on multiple validation sets, cross validation provides a more realistic estimate of the model's generalization performance. That is, its ability to perform well on new as well as unseen data. Types of cross validation. First one, holdout validation. In holdout validation, we perform training on 50% of the given data set and the remaining 50% used for testing purpose. It's a simple and a quick way to evaluate a model. The major drawback of this model is we perform training on only 50% of data. It be possible that the remaining 50% of data contains some important information which we are leaving while training our model, which provides normally higher bias. A second type is LOOCV, that is leave one out cross validation. In this cross validation, the model is trained on n-1 samples and tested on one omitted sample, repeating this process for each data point in the dataset. It has some advantages as well as drawback. The advantages of LOOCV is by using this method, we make use of all data points and hence it is low bias. The drawback of this method is it leads to high variation in the testing model as we are testing against one data point. If the data point is outlier, it can lead to high variation. Another drawback is it takes lot of execution time as it iterates over the number of data points times. The third type is stratified cross validation. It is a technique used in machine learning to ensure that each fold of the cross validation process maintains the same distribution as the entire dataset. In the stratified cross validation is essential when dealing with the classification problems where maintaining the balance of class distribution is crucial for model to generalize well to unseen data. The fourth type is k-fold cross-validation. In k-fold cross-validation, we split the dataset into k number of subsets, which is nothing but folds. Then we have to perform the training on all the subsets. That is k minus 1 subset for evaluation of the trained model. In this model, we iterate k times with different subset reserved for testing purpose each time. Thank you.